Am I the only one that didn't know how crucial JK flip-flops are in digital electronics? A flip-flop, sometimes called a latch, is a fundamental electronic circuit with two stable states, allowing it to store one bit of information. Think of it as a simple memory cell. It can be in one of two states, 0 or low, and 1 or high, representing binary data. The types of flip-flops are RS flip-flop, gated RS flip-flop, D flip-flop, JK flip-flop, and JK master-slave flip-flop. A JK flip-flop is a type of digital storage element widely used in sequential circuits. It's actually a modification of the SR or set-reset flip-flop that eliminates the indeterminate state that occurs when both inputs are high. The JK flip-flop is particularly useful because it can toggle its output state based on the input conditions, making it versatile for various applications. JK flip-flop has the following characteristics. It has two primary inputs, labeled J and K. It has two outputs, Q and Q. The flip-flop is typically edge-triggered, meaning it changes state on a specific edge, either rising or falling, of a clock signal. Some JK flip-flops may also have asynchronous inputs for setting or resetting the output regardless of the clock. No change when J is 0 and K is 0. When both inputs are low, the output, Q, remains unchanged. This is often called the hold state. Reset, when J is 0 and K is 1, when J is low and K is high, the output Q is reset to 0. Set, when J is 1 and K is 0. When J is high and K is low, the output Q is set to 1. Toggle, when J is 1 and K is 1. When both J and K are high, the output Q toggles between 0 and 1 on each clock pulse. Implementation. JK flip-flops can be implemented using various logic gates, often involving SR flip-flops and additional logic to handle the J equals 1, K equals 1 case. They are also available as integrated circuits or ICs. Applications. JK flip-flops are used extensively in a variety of applications. First, in counters. The toggle function, where J equals 1 and K equals 1, makes them ideal for building binary counters. Second, in frequency dividers. By using the toggle function, a JK flip-flop can divide the input frequency by 2. Third, in shift registers. These are used to store and shift data bits. Fourth, in sequence generators. They can generate specific sequences of binary numbers. And lastly, in state machines, these are used to implement complex control logic. Advantages. No indeterminate state. Unlike the SR flip-flop, the JK flip-flop does not have a condition where both inputs are high, which can lead to an undefined state. Versatile. It can be used for various functions such as set, reset, and toggle based on the input conditions. Disadvantages. Complexity. The JK flip-flop is more complex than simpler flip-flops like the SR or D flip-flop. Propagation delay. Like all flip-flops, there is a delay between the clock edge and the output change, which can affect high-speed circuits. Variants. Asynchronous JK flip-flops. These flip-flops can change state based on the J and K inputs regardless of the clock signal. Edge-triggered JK flip-flops. These change state only on the rising or falling edge of the clock signal. Conclusion. The JK flip-flop is a fundamental building block in digital electronics, providing a reliable way to store and manipulate binary data. Its ability to toggle states and eliminate indeterminate conditions makes it a preferred choice for many applications in sequential logic design.